Day 5 trig identities. Do not let a number in front of the trig identities scare you. Let's do an example. So let's say we have the sine squared of x minus cosine squared of x equals 1 minus 2 cosine squared of x. In this particular case, this 2 in front of the cosine, treat your cosines as though it's a variable. There's 2 of them. There's just 2 of them. We can manipulate either the first or the second to match. So I am going to, for this time, I'm going to try it the other way. I'm going to manipulate the second one. You can do either way, it would work. But let's say here, I can split up this cosine squared of x because there's only 2. That means there's 2 of them. So this is the cosine squared of x minus the cosine squared of x. And I already know 1 minus the cosine squared of x. Well, that's sine squared of x. That is sine squared of x minus cosine squared of x. And there we go. We have our solutions. Let's try a different one, another one that it takes a little bit more of work. Well, let's say we have 1 plus sine of x over 1 minus sine of x minus 1 minus sine of x over 1 plus sine of x equals 4 something happened there. 4 tangent of x secant of x. In this case, I'm going to simplify it. What I'm going to do is I'm going to multiply both fractions on the left by 1. The first fraction I'm going to multiply by 1 plus sine of x, right? Because I want the denominators to kind of go away. So I'm going to multiply 1 plus sine of x on the first one and 1 minus sine of x on the second one. So like so, we have 1 plus sine of x over 1 minus sine of x times 1 plus sine of x times 1 plus sine of x minus 1 minus sine of x times, I'm gonna put these in parentheses like so, 1 minus sine of x over 1 plus sine of x times 1 minus sine of x. I know that these are the difference of perfect squares, so the denominator instantly is going to be 1 squared, which is 1 minus sine squared of x. And then the numerator is going to be, we're going to just have to multiply this all out. I can multiply it out. Yeah, I'm going to multiply it out. I'm going to multiply it out and see what we have here. So we multiply it out. We get 1 plus 2 sine of x plus sine of x squared minus, remember the minus sign. So I'm going to put this in the parentheses just so I don't get confused. The second part, I get 1 minus 2 sine of x plus sine of squared of x. Now I'm going to distribute my negative. 1 plus 2 sine of x plus sine squared of x minus 1 plus 2 sine of x minus sine squared of x all over 1 minus sine squared of x. I'm going to just reduce now. I'm going to take this sine I know 1 minus sine squared of x. That's a cosine squared of x. Because I don't have a denominator there. So I'm going to just turn it into a cosine squared of x. So then if I simplify this some further, the 1's cancel out, doop, doop. If I add the sines squared cancel out, doop, doop. And then I am left with 2, that makes 4 sine of x over cosine squared of x. I want my answer to match tangent and secant. Well, let's think about this. Sine of x, isn't that my inverse? Well, it's cosecant. So, but cosine, isn't cosine? I can split this up into a cosine of x times a cosine of x. Sine of x over cosine of x is the same thing as saying tangent of x. So this is 4 tangent of x. And then 1, this is, right, sine of x over cosine of x, and 1 over cosine of x. And 1 over cosine of x is also the same thing as the secant of x. So this is secant of x. And that's how we can solve set 1 equal the other. Even though they have a number in front, use the numbers as though the sines and cosines, treat them like variables.